Okay, so significant figures are counted from left to right, starting from the first non-zero digit. So we can think of this sometimes as rounding. If you want to round, if you have lots of digits and you want to round to two or three significant digits, significant figures rather, we should find out which ones are significant. Zeros with no non-zero digit on their right are not counted. So this one, that zero is in the middle, so our first non-zero digit's there, 3. That has 5 significant figures. These first 3 zeros are not significant. These two are, 1 and 6, so we have 2 significant figures. I should be saying figures. And this one, 3.21, doesn't matter how many zeros come after that in this sense because we have 3 significant figures. When we use scientific notation, the first significant figure sits to the left of the decimal point. So as we did before, you have one number approaching 10, so 9 point something something something, and that's how we express something with scientific notation with respect to significant figures. So we're going to use the calculator to do this. This is really awesome. Our Sharp calculators, they use this button, but you might have a times 10 to the x or something, and it's really cool. So if we type in 2.37 and then we hit the exp to 5, that gives us 10 to the power 5, and it just gives the answer. And sometimes it'll just give the answer as scientific notation. So pretty cool. So state the number of significant figures in each of these. So in this one, 451, we have 3 significant figures. We don't have any zeros. We don't have anything before it or after it. The first non-zero number is 4, and so we count all those numbers. Now, we're going to ignore all these zeros until we get to that 5. So the first non-zero number is 5. Even though there's a 0 in there, we've got some other numbers after that. So this one is going to count for 4 significant figures. Again, we ignore everything that's 0 until we get to a non-zero number, and then we count it. So 3.2, even though we have 10 to the power of oodles, we only have 2 significant figures. I'm sure you could write out the whole thing. Write these numbers using scientific notation with only 3 significant figures. Okay, so at the moment, how many significant figures do we have? We have 4 significant figures at the moment. So we're going to find out how to express this as in scientific notation, and then we might have to do a little bit of rounding. So we only want 3 significant figures. So the first thing we do is take the 2, and then we add our decimal point after that. So when we're in scientific notation, we have a single digit and then a decimal point, and we're only allowed 3 significant digits. So we have 2.18. Because the critical digit here is 3 when we're rounding, that 8 is going to stay an 8 and it's not going to make a 9. So what do I have to multiply that by? What order of 10 would I multiply that back to sort of reconstitute it as 2,180,000-ish? That would be how many jumps? From here, 1, 2, 3, 4, 5, 6. So that would be 10 to the power of 6. So we have 2.18 rounded to 3 significant figures times 10 to the power of 6. So for this one, our first significant digit is 1. And we've got 5, so we're going to need to do some rounding. So we start by expressing this as 1.9. And again, we're allowed only 3 significant figures. So in this case, our third is 4, but our critical digit is 8. So that's going to make that number round up to a 5. And it's not going to make a difference in terms of the powers of 10. Yeah, it's still rounding, but we've been instructed that we can only have 3 significant figures. So we have 1.95 times 10 to the what will bring us back to reality. If I consider that my decimal point is there, I would have 1, 2, 3 backwards, and because I'm going backwards, I'm actually dividing. We're timesing by that negative power. Now this is where the fun begins. Use a calculator, and again our Sharp calculators, I'll show you this, to evaluate the following, and we're going to leave our answers in scientific notation or convert them back to 4 significant figures. So let me get my calculator up. Okay, so I'm going to type all of this into my calculator. So let me swap to my calculator. So I've got 3.67 times, and I'm going to use this exp button, and see it's got times 10 to the 5 times 23.6 to that exp button again, 10 to the power of 4, and that gives me this. So it has actually, in this case, already given me 8.6612 times 10 to the power of 10. But now I have to reduce that to, what is it, to 4 significant figures. So 1, 2, 3, 4. So because the critical digit is 2, then that'll be 8.661. Now for the next one, it's very similar. I'll start by, you can look at this in your book. I'm going to hop back to my calculator. So I've got 7.6. And instead of going 10 to the power of something, I'm just going to go exp, which says 10 to the power of what? Negative 3. And to that, I'm going to add the square root, where are we? That's our square root of 2.4 exp 10 to the negative 2, so that's going to be the negative button 2, and that's going to give me this. Now it hasn't gone and given me the scientific notation, and again we want to 4 significant figures, so I need to get that 1 to the decimal on that side of the 1, so the only way to do that is to divide by 10. 10 to the 1. So dividing by 10 to the 1 is multiplying by 10 to the negative 1, so I would have 1.625. That's 4 significant figures, and that critical digit is 1, so that stays the same. So I'll have 1.625 times 10 to the negative 1.